The United States has 95,000 miles of shoreline. These dynamic coastal regions are vulnerable to flooding, property destruction, and beach erosion from severe weather and sea level change. Coastal areas rely on accurate elevation data to plan and recover when hazardous situations arise. These communities depend on up-to-date information for their management and resiliency planning. As part of its mission, NOAA's National Geodetic Survey, NGS, provides an accurate, consistent, and current national shoreline. NGS's mean high water line is considered the nation's official shoreline. It is used to create and maintain NOAA nautical charts. These charts are used by commercial and recreational boaters to navigate safely and avoid potential hazards. NGS's shoreline is also a crucial source for defining our nation's boundaries and territorial limits. Remotely sensed data from aircraft is collected to map the shoreline. The use of aircraft-based sensors, such as a digital camera and Topographic LiDAR system, allows large areas to be surveyed in a short amount of time. LiDAR, which stands for Light Detection and Ranging, is a remote sensing method that uses a laser to measure distances to a surface. NGS uses a unique type of sensor called Topographic LiDAR. It collects wide swaths of elevation data on both land, or topography, and in shallow water areas, or bathymetry. Bathymetric data has historically been difficult to acquire in these highly dynamic coastal zones, since NOAA survey ships cannot travel safely close to the shoreline. NGS's Topographic LiDAR system uses a green laser that operates in a circular scan pattern to penetrate shallow water near the shore. The high-density point data is combined with GPS and other positional data to create precise 3D topographic and bathymetric elevation models. NGS uses coastal elevation data to map the mean high water shoreline, which is a tidally referenced boundary. The shoreline is verified using aerial imagery that is collected along with the LiDAR data. Topographic LiDAR data, collected by NGS, is freely available from NOAA's Digital Coast to use for applications and tools to support decision-making in the coastal zone. Academic and research organizations use coastal elevation LiDAR data to develop ocean and coastal models. These 3D models help researchers understand ocean circulation. Elevation data is an important part of the model because circulation is influenced by friction, which is related to the height of the seafloor. Coastal engineers and scientists use elevation data to understand sediment movement, beach erosion, and sediment budgets. This information is used to develop management plans to restore, monitor, and maintain beaches in the coastal zone. Elevation data is also one of the most important parameters for modeling inundation. Topographic LiDAR data is especially valuable due to its accuracy and its seamless transition from land to water. Coastal managers and decision makers use visualization tools that incorporate these elevation models to understand vulnerability, increase resilience, and develop hazard mitigation plans. These are only a few of the many ways that elevation and shoreline data are being used to help keep coastal communities safe and resilient. NOAA Topographic LiDAR data is a critical component for meeting the challenges of an uncertain future.